Welcome back to the video. We are going to cover the previous lecture and we cover 6 slides in the previous lecture. So we are going to start from the slide number 7. Let's start the video. Input output addresses. When connected to a computer system, each device port is assigned an IO address. A device port is identified by its IO address. Computer will read and write from to this IO address to receive and send data from from to device. In microprocessor architecture, there are two kinds of IO address connection: isolated IO and memory mapped IO. Let's move to the next slide. Uh, IO input output addressing schemas schemes isolated input output Intel. Well, basically Intel use the isolated IO, and we you are going to see in the next slide. Basically there is an example in the next slide. um, the microprocessor has dedicated instruction for IO operation, and microprocessor has a separate address space for IO devices. IO addressing schemes, so memory mapped IO and this is isolated IO, and the slide number 9 is memory mapped IO. You can also see from the diagram, and the microprocessor uses the same instruction set to perform memory access and IO operation. The IO devices and memory component are resident in the same memory space. Okay. Intel, basically I am telling you about this slide. Intel uses isolated input and output within 80 by 86 family. Input output address range is 0 for FFFFH, and for this PC device are assigned standard IO addresses. Keyboard has 60H data port, and speaker has 61H data port. Parallel printer use 3BCH data port and 3BDH status port, 3BEH control port. Just because a port might allow a value to be written to it does not mean that a port can have a value read from it. Let's move to this right now. Next slide. IO instructions, input output instruction. Intel use the isolated IO address scheme. IO ports and memory address can have same value but represent location in two separate address spaces. There are separate instructions that transfer data to from IO ports. Okay. Let's move to the next slide. Intel 8086 IN instruction. You can pause the video and read it by yourself and understand it by yourself. This is your task. I am going to move to next slide. I am going on the next slide. Intel 8086 out instruction. This is also a part of the previous slide, and there are some examples, IO examples. Suppose we have a display device for ASCII characters. The program model is a single write only data port at IO address A04E9H. The display in cursor driven the ASCII character written to the data port is a display at the current cursor position. Cursor position is maintained by a display device. What character is written? Cursor position is advanced. Advancement handles new lines and scrolling to write a code fragment showing the display of character A. Okay. And the next slide is also a solution of this previous slide. Write a code fragment showing the display of character rate. This is basically this is a code fragment of how to display a character rate of ASCII code. Let's end the video on the slide number 15, and we will continue this lecture in the next video.